In this module, we turn theory into a concrete supply chain scenario. You'll trace how products, data, and compliance evidence move across companies, then design a blockchain-based trust layer that plugs into existing systems and satisfies regulators, auditors, and business stakeholders. Imagine a critical medicine moving from raw materials to factory to ship to distributor to pharmacy. Each step runs its own ERP, its own version of truth. When something goes wrong, recall, fraud, stockout, no one sees end to end. That visibility gap is the trust problem we'll tackle. In a black box ecosystem, every question becomes expensive. Is this record authentic, and who vouches for it? Could you withstand a surprise audit tomorrow morning? If a regulator, minister, or customer challenges your data trail today, how confident are you in the story your systems can actually prove? To design any blockchain-based trust system, you first need a clear view of the stakeholder landscape. Each actor has a different trust problem. Manufacturers care about verifiable product quality and batch lineage. Logistics providers need strong proof of custody and condition during transport. Retailers focus on authenticity and protection during recalls. Regulators want timely, reliable audit evidence. Your architecture has to align these interests while avoiding any one party becoming a single point of trust. A glass pipeline means every party shares the same verifiable story of what's happening, end to end. Each organization runs a permission node, so participants are known and governed, not anonymous. They still keep their own ERPs and warehouse systems, but those systems synchronize through an integration layer of APIs. The shared ledger becomes the single source of truth for orders, movements, and handoffs. When manufacturer, logistics provider, and retailer all write to that ledger, disputes drop, audits get easier, and regulators can be granted controlled, real-time visibility. For traceability, start by deciding what you're tracking. Typically, that's a product master, plus batch or lot identifiers. Next, model the life cycle as a sequence of events: manufactured, shipped, temperature checks, delivered. Each event links back to those identifiers, so you get a continuous digital thread. On-chain, you keep the minimum needed for integrity and automation: hashes, IDs, timestamps, and status transitions. Off-chain, you keep bulky or sensitive content: documents, certificates, sensor payloads, and anything with PII. The discipline to remember is simple: identifiers and proofs on-chain, rich data off-chain. In regulated consortia, the core tension is clear. Regulators demand transparency, while participants must protect competitive data. Blockchain doesn't magically solve that. You have to design for it. Use logical partitions or channels, so only the parties to a relationship see the full transaction. Others see only proofs or summaries. Minimize what you put on chain. Often a hash, timestamp, and policy ID are enough for audit and legal evidence. Where needed, apply selective disclosure and zero-knowledge style techniques to demonstrate compliance without exposing pricing models or trade secrets. When you bridge blockchain with the physical world, the weak link is usually data entering from devices. Take a temperature-controlled shipment. A sensor measures temperature and GPS, but the ledger should never just trust the reading. Give the device a strong identity and keys, anchored in PKI or secure hardware. Have data signed at the source, checked by an IoT gateway for sanity and policy compliance, and only then forwarded through an oracle into a smart contract. From there, rules can be enforced automatically, triggering alerts, holding shipments, or blocking non-compliant flows. Deploying a blockchain network across multiple organizations requires governance to prevent chaos. Think of it as the rules of the road: who's allowed to join, who can vote, and how disagreements get resolved. You typically distinguish founding members, regular participants, and observers, each with different rights. A steering committee sets strategy and policies, while a technical committee turns those decisions into concrete standards, upgrades, and security requirements. Operational onboarding for a blockchain trust network is a pipeline, not a single step. Start with legal agreements that define liability, data responsibilities, and governance obligations. Without this, every later security control sits on shaky ground. Then address technical readiness: secure connectivity, hardening baselines, logging, and change control so nodes behave like any other critical system. Next, the membership service issues identities, keys and certificates tied to organizational roles and approval workflows. Finally, run coordinated go-live testing to validate end-to-end security, failover, and operational playbooks before production traffic flows. In regulated environments, a phased rollout is usually safer and more persuasive than a big bang launch. Begin with a constrained pilot, a single product line, a limited set of agencies or business units, and one or two critical workflows. Use this to harden operations, validate consensus settings, and prove basic SLAs. Then scale by adding more participants and more complex workflows, such as cross-agency approvals or automated recalls. Only once those layers are stable do you move to full integration, regulatory reporting, and advanced analytics across jurisdictions. Introducing a blockchain trust layer is not just a technology rollout, it's an organizational change. 3 levers matter most. Process mapping translates today's manual checks and reconciliations into concrete, automated events on the ledger. Targeted training gives ops and compliance teams role-specific guidance, not generic blockchain theory. And incentive alignment highlights measurable wins like faster audits, fewer disputes, and clearer accountability. When blockchain becomes part of your trust infrastructure, the ROI of trust shows up in time, effort, and risk. Traceability moves from chasing paper or siloed logs for days to querying a shared, cryptographically verified history in seconds. Disputes shift from manual investigation across teams to automated reconciliation based on a single, agreed ledger state. Compliance changes from audit panic to being continuously audit-ready because evidence, controls, and lineage are already encoded in the system. These are the outcomes you're really designing for. As you design blockchain-based trust, 3 risks keep recurring. First, data quality. Once bad data lands on an immutable ledger, you've created permanent, trusted garbage. Second, integration fatigue. Legacy systems and teams will push back if the design is too intrusive. Third, privacy. Misconfigurations can overexpose sensitive data. The lesson is to standardize data early and embed governance, privacy, and compliance from day one. Throughout this course, we've treated blockchain not as hype, but as a way to move from scattered, fragile silos to a shared, verifiable fabric of trust. A unified network means every party can see the same truth, prove what happened, and keep operating even when individual systems fail. As you apply these ideas, focus less on the chain itself and more on what it unlocks: resilient, interoperable, governed collaboration.